When solving an absolute value inequality, you may get a statement that is true for all the values of the variable. In this case, all real numbers are solutions of the original inequality. All right, so let's go ahead and look at an example and see what we are talking about here. So we're going to solve this, and we're just going to use the same process that we have done previously. We are going to isolate this absolute value expression, okay? So let's go ahead and do that. We need to get rid of that positive 7 by subtracting 7 to both sides, okay? What we're left with is the absolute value of x minus 6 is greater than 2 take away 7 is negative 5. Okay, so the big thing here is that whenever you, just like with absolute value equations, okay, with absolute value inequalities, when you isolate this absolute value expression and it ends up on the other side getting a negative number, okay, when you get a negative number here, you have to think, oh my gosh, like a light should be going off. Okay, alert, alert, alert. So this means you're gonna have an answer a little different. So let's go ahead and think about this. What is this saying? X minus 6, the absolute value of that is greater than negative 5. Okay, so what do we know about anything that's inside absolute value symbols? Okay, so let's say any number, okay, like absolute value of 20, it's going to be 20. Absolute value, so absolute value of any positive number is just going to be itself, positive. And the absolute value of like negative 12 is then going to be positive 12, okay? So that means that the absolute value of any positive number is going to be a positive number, okay? So the absolute value of a positive number equals a positive number, and the absolute value of a negative number equals a positive number. So no matter what, you are always going to get a positive result when you're dealing with absolute value symbols. So that's really important here, because when we look at this, what this is basically saying, x minus 6, it doesn't matter what x is. We know that whatever it is at the end of the day, when you take those absolute value of whatever number this ends up being, we are going to end up with a positive number. And what do we know about a positive number? Is a positive number always going to be greater than negative 5? And the answer is yes, it will be. That means that our answer, like what was stated up before, is this. It says, when solving an absolute value inequality, you may get a statement that is true for all values of the variable. So look here, we have a statement down here. This is going to be a positive number, and a positive is always greater than a negative 5. This is a true statement. So it's true for all values of the variable. So in this case, all real numbers are solutions to the original inequality. Okay? So what we see here is we see this is a true statement. So when we see that negative, we read the statement, it's a true statement. So we know that the answer is all real numbers are solutions. Or a lot of times we say that as infinite solutions. This problem has infinite solutions. Okay, so that is the answer. All right, now let's go down here. Now I just wanted to show you how you graph something that is all real solutions. And when you graph something that's all real solutions, you literally just graph everything. It's like everything. You put arrows on both sides of it. And yeah, that's it. It's literally goes on forever. Everything is a solution. Right here and here. All right, so all real solutions. Okay, let's look at the next one. This says, when solving an absolute value inequality, you may get a statement that is false for all values of the variable. In this case, there are no solutions of the original inequality. All right, so let's look at this next example. Okay, we have this absolute value expression. Is it by itself? It is not. We have to get rid of this -5, right? So we have to isolate the absolute value expression. Let's go ahead and do that by adding 5 to both sides. So we're going to end up with this. I really think that this is, I'm going to actually change this because this is not right. This is supposed to be a +5 here. Right there. Let me use my lovely little whiteout right here. Okay, there we go. All right. Okay, so this is what we're supposed to be doing. So we're isolating. Okay, this is supposed to be a +5. I think there's a typo. So we have to do the inverse operation, which would be a -5 to both sides, right? So when we do that, this cancels out, and we have -1 minus 5, which would be a -6. And just like the last problem, wait, hold up. There's a negative number here. So we have to really take notice of that. When you isolate this absolute value symbol and there ends up being a negative number on the other side, you really have to think about what this says and interpret. All right, so basically, what is this saying? We know the absolute value, we know that this is going to be a positive number. When we take the absolute value of whatever this is, it's going to be a positive number. So let's think about this. Is a positive number always less than or equal to -6? No, it is not. This is a false statement. And if we go back here, when solving an absolute value inequality, you may get a statement that is false. You might get a statement that is false for all values of the variable. In this case, there are no solutions of the original inequality. Okay? So it doesn't matter. We're always going to have a positive number, and a positive number is never, it's never going to be less than or equal to -6. Positive numbers are greater than -6. So this is a false statement, which means our answer is no solution. So really the key when you're solving these and you isolate that absolute value expression, you need to figure out if it's a positive number, you split it into 2 like we've been doing. If it's a negative number, you need to go ahead and think about, okay, if this is a positive, read this, and if it's a true statement, it's going to be infinite solutions. If it's a false statement, it's going to be no solutions. Now let's think about this. What does a no solution graph look like? And really, this is what a no solution graph looks like. It looks like nothing, okay? So this is the graph of no solution. So if you ever have to graph something for no solutions, you just put a number line with nothing on it, all right? Okay, let's look at a few examples here. So solve each inequality, and we're gonna graph the solution. So first, we're gonna isolate that absolute value symbol. We're gonna do that by adding 9 to both sides. We get the absolute value of -11 plus 9 is -2. Oh, wait, hold up. This is a negative number, right? We've isolated it and it's a negative number. So we know this is going to be a positive greater than negative 2. So is a positive number, this is always going to be a positive number. Is a positive number greater than or equal to a negative 2? Yes, it's always, positive numbers are always going to be greater than negative 2. So this means infinite solutions. It's a true statement. It means infinite solutions. And we just need to graph our results. And remember, whenever you graph something with infinite solutions, it's really just everything on that graph. And big arrow going forever in both directions, because it doesn't matter what x is. It can be anything, and it will always be true. Okay, let's look at the next example. All right, so we have to isolate this absolute value expression. This is 4 times, so we have to do the inverse operation of multiplication, which would be division to both sides. We end up with the absolute value of x minus 3.5 is less than or equal to negative 8 divided by 4 is negative 2. Wait, hold up. This ends up equaling a negative number, so we have to interpret these results, okay? We know this is always going to be a positive, right? So positive less than or equal to negative 2. So is a positive number less than or equal to negative 2? A positive number is never going to be less than negative 2. So this is a false statement, which means our answer is that there are no answers. Our answer is no solution. So when you do this, you have to state an answer. This is your answer. If you just say false or you say true, you're not going to get full points. You have to say, this says solve each inequality. When you solve the inequality, you have to say what the answers are. The answer is that there are no answers. There's no solutions. Up here, it's infinite solutions. So, and then when we have to graph it, you just leave it blank like this. All right, that's it for this part. We'll see you in a little bit for the next examples.